I want to go over the practice for the anchor assignment that you'll be doing later on in the class. The first, it says perform the indicated transformations of the graph below. List the coordinates of the transformed function and graph the transformations. I'm going to call what the graph looks like before the transformations the pre-image, and what the graph looks like after the transformations the image. For the first function, you have 2 times f of x minus 2 inside the parentheses plus 2. The x coordinates, you're going to add 2 to each of the x coordinates because of x minus 2 inside the parentheses. The rules are the same for transformations that we've had for all the graphing. Inside the parentheses, if it's x plus 2, it moves 2 to the left. If it's x minus 2, it moves 2 to the right. So in this case, all the x coordinates, you're going to add 2 to it, or it's going to move them 2 to the right. Then, since there's plus 2 outside the parentheses, that's going to translate up by 2. However, before you translate up by 2, you have to keep in mind, right here where it says 2 times f of x minus 2, you're going to first multiply each y coordinate by 2. That's going to be what they call a vertical stretch of a factor of 2. And then after you get a vertical stretch, after you multiply each y coordinate by 2, then you're going to add 2 to translate the graph up. So the pre-image coordinates of these 4 points are negative 3, 1, negative 2, 2, negative 2, 2, negative 4, and 4, 3. You can check out which each one of those are. For negative 3, 1, since we're going to add 2 to each of the x coordinates instead of negative 3, it's going to become negative 1, because negative 3 plus 2 is negative 1. Then we're going to take negative 1 and we're going to perform two parts to the translation. You're going to multiply negative 1 by 2, changing it to negative 2. Then you're going to add 2 to that, which makes negative 2 plus 2, 0. So negative 1, the y coordinate, becomes 0. Negative 2, 2, you're going to add 2 to negative 2 and get 0. You're going to take 2, multiply it by 2, giving you 4, then add 2, which gives you 6. And so on. 2, negative 4 becomes 4, negative 6. 4, 3 becomes 6, 8. And you'll see in red, the image is the pre-image with the translations applied. With the transformations applied. For number 2, you have no changes for the x coordinate because nothing happens inside the parentheses. Since you add 6 outside the parentheses, you have a vertical translation up, or up 6 units. You're going to, in essence, add 6 to each of the y coordinates. All the x coordinates stay the same. All the y coordinates have 6 units added to them. 3, negative 1 becomes, negative 3, negative 1 becomes negative 3, positive 5. Negative 2, 2 becomes negative 2, 8, and so forth. And you'll see red is the image of the transformations after they're applied to the black pre-image. If we move on to the next page, you'll see that for number 3, it says negative 2 times f of x. So what you're going to do is there's 2 things happening there. The negative sign means that you're going to reflect this across the x-axis. You're going to reflect the pre-image across the x-axis, and you're going to have a vertical stretch of a factor of 2. Your x-coordinate is not going to change at all. So the pre-image, again, is negative 3, negative 1, negative 2, 2, 2, negative 4, 4, 3. The x-coordinates are going to stay the same. The y-coordinates you're going to, in essence, multiply by negative 2. So negative 1 becomes positive 2. Positive 2 becomes negative 4. Negative 4 becomes positive 8. And positive 3 becomes negative 6. The red is the image. The black is the pre-image. For number 4, it looks really complicated, but it's really not. All you're doing is you're translating to the right 4 units, and then you have a vertical compression, which is the opposite of a vertical stretch, because you're going to make the y-coordinates smaller, because you're going to divide them by 2, which in essence is multiplying them by 1/2. So your x-coordinates, you're simply going to add 4 So negative 3 becomes positive 1, negative 2, positive 2. 2 becomes 6, 4 becomes 8. You're then going to take your y coordinates and divide them by 2. Negative 1 becomes negative 1 half, 2 becomes 1, negative 4 becomes negative 2, 3 becomes 3 halves. And then you can see if you graph it, the black is the pre-image, you apply your transformations and you get the red image. Now, it says, write a transformation in function notation that shifts a function to the left 5, up 2, and reflects it across the x-axis. I made a judgment call on this, and I think that there is, what it should say, I think, is write transformation in function notation that reflects it across the x-axis, shifts it to the left 5 and up 2. Otherwise, as it's stated, you should apply parentheses, but I'm not going to do that because I don't think that was what was the intent. So it says, I'm sorry, it says write transformation in the function notation that shifts a function to the left 5. If you're going to the left 5, you add 5 inside the parentheses to x, so you get x plus 5 inside the parentheses. Up 2, you're going to add 2 outside the parentheses. Reflected across the x-axis, you're going to multiply f of x by negative 1. So you get negative 1 times, or the opposite of, f of x plus 5 inside the parentheses plus 2 outside the parentheses. Next, you need to write the equation of transformed function given the original equation and the transformations performed. So the original equation, which would be considered the pre-image if you graphed it, it says f of x equals 1 over x. Now it's stretched vertically by a factor of 5. That means you're going to multiply f of x by 5. Or you could say 5 times 1 over x, and when you apply that, it becomes 5 over x. Then you need to translate 5 units to the right. So inside the parentheses is going to be x minus 5. Then it's 2 units up, so you're going to add 2 outside the parentheses. When you put it all together, that should have parentheses around it, I apologize. That should be f of x equals 5, because you multiplied by 5, divided by x minus 5, which is translated 5 units to the right, plus 2, which is 2 units up. For number 7, you have 2 things going on. Your original equation, or your function of x, is f of x equals the absolute value of x. Now you have it reflected over the x-axis, which means you need to multiply by negative 1, and then translated 2 units up. Outside the parentheses, you're going to add 2. F of x equals the opposite of the absolute value of x plus 2. For number 8, you have 3 transformations that are going on. The original function is f of x equals x squared. It's compressed vertically by a factor of 1/3, so that just means you're going to multiply by 1/3. You're going to multiply whatever x is by 1/3, and in this case it's x. It's originally x squared, but because it's translated 2 units to the left, it'll be x plus 2 quantity squared, and then it's 4 units up, so outside the parentheses you're going to add 4. F of x equals 1/3 times the quantity x plus 2 squared plus 4. What I'm going to have you do is you're going to take the anchor. You'll have some time to work on the practice sheet. Take the anchor. If you do well on it, you don't have to retake it on Friday. If you don't do well on it, you retake it on Friday, and I'll allow you to ask questions beforehand. If everyone completes it satisfactorily, we'll move on, and that would be in everyone's best interest. So don't just take this class as a free-for-all. Apply yourselves. Work together when you're preparing for the anchor. It is not difficult. It's very similar to this practice. If you can do the practice, you can do the anchor.